Hello and thanks for joining me. Well, today we're going to fix this 4-jaw chuck that goes on my Hardinge lathe. I've been kind of avoiding it because I wasn't sure how to do it exactly. And I've thought about it a long time. Let me show you what the problem is and I'll tell you what we're going to do with it. Okay, that's the part that fits on the spindle on the Hardinge. And it goes right in there, bolts on through here. And it's made similar to most 4-jaws, independent 4-jaws. That little worm drive there goes there. These little pins go in the back and hold it. Anyway, the problem is this key that the chucks go into is broken. See, there's part of the key there and it's missing here. And there's 2 slots that are completely broken out. So there's nothing for the jaw to slide in. So I thought about taking a little, what do they call it, woodruff key cutter and slotting that like this drawing here, like that, and then inserting and brazing a piece of steel in there. Well, brazing is not something I'm really good at, and that would be, if I got some braze on the underside of that little piece right there, it would be an obstruction for the key to, or the jaw to slide in there. So I kind of ruled out that method. So over here is what I'm going to do now. I've got this 1/2 by 3/8 stock, and I'm going to cut a piece to fit in here. And it'll look kind of like that. It's going to be really particular. I mean, it's going to be some precise machining because I don't want any slop in these jaws. And it's got to slide freely. Anyway, I've not been looking forward to it, but I've got all the dimensions here and I'm going to cut it down like that and then mill a slot in the jaw, or in the chuck body, and bolt it in place. So first thing we're going to do is make these pieces right here. Oh boy, it fits right on there perfect. You know what? I think it might be just a little bit tight. Let me check a couple other jaws. Okay, I need to move it about 1/1000 because I'm just a little bit tight there. Okay, there's about 3/4 of a thousand. I didn't even see any chips coming off of there. Oh, that's better though. Yep, that's it. Now I've got to move the stock in my vise to complete that cut. Okay, the jaws fit really well on there, but I need to knock the corner off of that because it's got a little bit of a radius in the bottom of that slot there. Might be better just use this. I think that's it. Now we got to mill the chuck body so that this bar fits right in there. It's probably going to be fun. I'm going to set this up on a rotary table and center everything. There's one ring on this rotary table that lines up with the outer perimeter pretty good. So I should be able to put a dial indicator on the outside and tap it around and get it exactly center, I hope. Well, that's pretty darn good. Let me tighten it down and see what I got. Okay. There is no good way to center this accurately on the rotary table. So what I'm going to have to do is touch off inside where the jaws were sliding and set the rotary table so that I'm traveling parallel. Well, it's really close though. Very close. Lock down the rotary table. Kind of hard to see, but I'm perfectly in the center. Okay. This way, I need to go this depth right there, which is 410. And this way, I need to go 3/8 of an inch. I think I'll go the 3/8 of an inch full depth and just go slowly that direction until I get the right depth. Okay, I dropped the knee just a little bit. I want to sneak up on both dimensions. It's close to 3/8 of an inch, but it's not quite. Okay, I cut the inserts to rough size, put them on the jaws, and measured that, and then measured the slot that I have. I've gone 400 thousandths each way, but I need to go, doing the math, I need to go 48 thousandths more on each side. So I'll go about 40 and then check it again. That's why I didn't make it full depth. It looks like this is engaging really well. Kind of hard to tell. Looks like I could go down a couple more thousandths. It's really engaging pretty good right there though. Well, I didn't go quite full depth right there. I'm a little bit afraid to. It's meshing good with the worm, and it fits good in there. I'm leaving well enough alone. Well, it looks like it's coming out good. Everything's fitting right. I got to cut a miter here. To cut that miter, I'm going to tip my mill head here. And I've got it fairly well trimmed. I want to be able to get back to it, so I'm going to scribe a line right here. I've never had the mill tip since I put the VFD on it and the DRO. I'm not sure. Hopefully I won't run into any obstructions here. Well, that's not clamped in there the best, but if I take it easy, I think it'll work. Well, there it is with all the slides and the jaws in place. I got a plan. I don't know if it's going to work. I got to drill and tap these and put some flathead screws in there. But to hold these in place while I'm drilling and tapping, I'm going to try super gluing it. Super gluing these pieces in. I've cleaned these super well. I'll go over it one more time with MEK before I glue. But I bought some super glue that's specifically for metal, and I don't know if it's going to work good or not. We'll see. But I got a test piece over here by my vise. Let's go take a look at it. Here's the glue I used, and I'm not promoting the glue. I don't know if it's any good or not. But so far it looks good. I glued that yesterday. Just put a bead on the edge of it and stuck it to that block. And I cannot break it. I mean, it's strong enough where I cannot break it. But let's see if I can break it in the vise. No problem. But what I'm hoping is that it will hold those pieces in place well enough to where I can secure them with one screw, and then I'll finish drilling. So that's the next step. I'm going to glue those pieces in. Wish me luck. Well, I'll let that dry 24 hours at least, and then we'll try drilling and tapping those and see what happens. Hopefully they won't break loose. Okay, I'm getting ready to drill these. I'm going to use 832 screws and countersink them. I'll probably drill and tap first, put a bolt in, and then start countersinking, because I don't want this to move. It's been glued for about 4 hours and it feels solid, but I want one screw in there before I try to countersink. I'm afraid the torque on the countersink will break them loose. But I think we're in good shape. What I'm going to do now is zero this way and then zero this way with my center finder using my DRO. I'm definitely no expert on this, but this particular function is really handy. Okay, I'm finding the edge of one side. Right there. Click 0. Find the edge on the other side. And click this X. And then you hit the half function right there. And let's put that, it did say 700,000. Now it's 348. And then you just re-zero that axis. and it's dead on zero there. So I'm going to do the same thing on the next axis. Okay, what I just did is found the edge of this right here and then moved it 100 thousandths, which is half the diameter of that probe right there. So if I put a drill in there, it'd be drilling on that corner. So now I'm going to put a center drill in there. Okay, this is 400 thousandths, I think. 406. So I want to go, if I go 200, that'd be center, and then I want to go a little past center. Okay, this is just a best guess. This is going to be bored out. I'll knock the corners off of this. So I'm going to put 2 screws in there. I'm taking notes on the positions as I go. Okay, I just drilled 2 clearance holes through that 3/8. So far so good, nothing's broke loose. I'm going to do these 2 and then these 2 and these 2. Whew. I'm using the knee to do it with because the depth on my quill is kind of hard to read. I just feel I got the DRO to go by. Okay, I've got a hole in each piece drilled for clearance. Now I'm going to drill the tap size drill. This jaw's a little tight for some reason. I think it'll loosen up, especially if I oil it. Well, it's looking good. Looking really good. Well, we're just kissing the chuck body now fairly evenly, which is a really good thing. Well, one of my viewers, Haas Anderson, gave me this some miniature boring bars and end mills. Getting a chance to use that boring bar now. Working good. Thanks, Haas. Wow, that's working good. Let's see, number 4. This was the position that was messed up. It's doing good now. The problem was this little hex or square drive is split a little bit on the end of that. Yeah, this one's binding a little bit too, not much. It's not the jaw, it's the worm drive screw. It's split on the corners from torque. I probably need to address that. I'm just not sure how to do it. Anyway, let's chuck something up in here and see how close or how straight it is. See if we got wobble. Well, there it is, and it's not perfect, but I'm fairly pleased with it. I didn't really know what to expect. I didn't know how much wear the jaws had. It's pretty much dead on right there, and you can see the wobble there. I don't know if that bar is straight. I suspect it is not. I don't have anything real straight to put in there right now, but I'm pretty well tickled with that. That was a whole lot of work. I don't know if it was worth it or not. It's a very usable chuck now, though. I like it. Anyway, the use of a rotary table wasn't entirely necessary. I could have bolted it to my table and done the same thing. The rotary table kind of made it easier to keep things aligned, but I'll tell you what, I admire some of the older machinists that didn't have DROs. All those holes right there, had to go back and locate them several times to drill them, tap them, countersink them. Would have been a lot more difficult if I had to go by dials, accounting for backlash. DROs are amazing. Anyway, that about wraps it up for today. Thanks for joining me, and be sure and subscribe.